Now, before I dig into that, though, I want to just explain this theory that scientists use today to say that the Earth is millions and billions of years old, and that's the uniformitarian theory. And some of you know that from previous classes, previous lectures. But the uniformitarian theory basically says that the same slow processes, whether it's geologic change or whatever change, and the current rates and magnitudes are all that's required to determine the age of the Earth. And I've used the example of the Grand Canyon before. The Colorado River erodes a little bit more of the floor of the Grand Canyon every year. And so scientists will say, well, see, if it does just, an inch a year, then it would have had to take millions of years to carve out the Grand Canyon. The same can be true when you talk about carbon dating or radioactive dating. The assumption of the half-life is that it's always been the same. It's never changed. It's always been 5,730 years for carbon-14. And so that's the key that they use to determine whether the Earth is old or not. And we're going to use that same theory tonight to prove that it's not millions and billions of years old. So we'll go into it tonight. So let's dig in and see what the science really says. Now, we're not throwing out science. There's perfectly good science that we use all the time. But it's science properly understood, observational science. So let's start with this cartoon. Ed here is looking at his computer, reading the latest headline, and it says, "The problem with you creationists is that you don't believe in science." Ed was stunned as he looked through his laser surgery-corrected eyes at the message emailed to him over his digital internet hookup to his 1.33 gigahertz portable computer with the latest whatever. So, is it really true that we don't like science? I mean, most of the secular world would say, young Earth creationists, you've thrown science out. But we use science every day in our lives, don't we? I mean, we've sent rockets to the moon, we've got computers, we've got, cell phones. Science, by definition, it has to be observable, testable, repeatable, and falsifiable. That's observational science here. And no young Earth creationists that I know will reject observational science. Now, it's interesting, the whole thing about falsifiability. The ability to withstand criticism to prove something false. And I just read an article that says, does science need falsifiability? And it's interesting because scientists today are saying, maybe we need to throw that part of it out. And I'll just read a few pieces of this article. It says, scientists are rethinking the fundamental principle that scientific theories must make testable predictions. It says, some scientists and philosophers think it is time to reconsider the notion of falsifiability. Could a theory that provides an elegant and accurate account of the world around us, even if its predictions can't be tested by today's experiments or tomorrow's, still count as science? That's the question that they're asking themselves. Let's throw that out because it still is science. We are in various ways hitting the limits of what will ever be testable. As theory pulls further and further ahead of the capabilities of experiment, physicists are taking this question seriously. We're in various ways hitting the limits of what will ever be testable unless we have misunderstood some essential point about the nature of reality. We have now seen all the visible universe, and only gravitational waves remain to test further, and we are approaching the limits of what particle colliders can tell us, and that can be effectively and technically feasible to build. So what they're saying is, we've seen almost everything that we need to see, or what we can see, and so we're going out in these limits of things like string theory that can't be proven. And so they said, well, it's a perfectly good theory. Why do we have to be able to prove it and test it? So we're on the fringe of science here, and they would like to get rid of that particular aspect of what defines true science. Now, on the other hand, historical science, and I've said this before, it attempts to use evidence in the present to explain what's happened in the younger creationists would have a problem with historical science because we weren't there in the beginning. The only person that was there was God in the beginning of creation. So all we have are man's fallible opinions and his fallible theories that seem to change all the time with the latest discoveries. And you see, what we'll find tonight is that none of their scientific theories are about the universe, the creation of the universe, are not testable, repeatable, observable, and falsifiable. You'll see that as we go through tonight. So as I said, there's hundreds of physical properties in the world that set limits on the age of the Earth, and 90% of those give ages of less than millions and billions of years that they're requiring. Now, tonight I'm only going to talk about 10, so you don't have to worry about a long lecture, but we will talk about 10 of them tonight. So when we look at these 10, to show that the Earth is young, like I said, we're going to use the same uniformitarian theories, the same uniformitarian principles that scientists use to tell us that the world is millions and billions of years old. Now, I'm here to tell you, this isn't the best science, but I'm going to use their science against them to prove that there are things that if you use these uniform rates, you don't get millions and billions of years. Now, these are going to be maximum possible ages. I'm not saying that I agree with some of these ages that we come up with that are going to be millions of years, but they're not actual. They're the maximum possible age using this uniformitarian principle. The ages are still younger than what an evolutionist would require in his own experiments. And some that we'll find are still within the 6,000 to 10,000 year biblical age of what Scripture says about Genesis. And when scientists get these other ages that aren't quite the age that they think about it be, they always try to fit in these improvable, improbable assumptions to have an answer for why they didn't yield the millions and billions of years. Or they throw it out because of some scientific error. So let's jump into this. This is the first evidence for a young world, and that is that the spiral galaxies still exist. If you look at these galaxies, you can see these beautiful spiral arms, well-defined spiral arms in these. Now, if the world was millions and billions of years old, you should be able to see that. In the mid-1990s, the Hubble telescope gave us an image. This is called Hubble's Deep Field View. And this really gave us the first image, the first real insight into the galaxy population that we see in our known universe. Now, this happens to be a few years later, 2003 and 2004, when Hubble took this ultra-deep field picture. Now, this is a view that represents 1/13,000,000th of the nighttime sky. If you had a piece of paper that was 1 millimeter by 1 millimeter, and you held it out at a meter's length, that's the area of the sky that would be covered that represents this picture. So the Hubble telescope saw all these myriads of galaxies out here, and before this picture, scientists thought that there was only about 200 billion galaxies. Now they recognize that was at least tenfold too small. So what an amazing God we have, and I would say the heavens declare the glory of God and the skies proclaim the work of his hands. I mean, there's no other thing that you can say about a God so majestic, we can't even see to the outermost limits of his world that he created for us. Now, here's another galaxy. This is the M51 Whirlpool galaxy. And notice all these beautiful spiral arms. Now, there seems to be some disagreement from scientists as far as how fast individual stars rotate around the galactic center. Some thought that the stars in the center rotated faster than the stars on the outside in the arms. And some astronomers now are saying, well, it really seems like the stars are all rotating the same speed. But there's not much consensus out there in the scientific world And some actually believe that it depends on whether the galaxy is old or whether it's young, and they see a number of different phenomena out there that kind of supports all of it. But for this scenario that we're looking at, we're going to assume the best case possible for the evolutionists, and we'll say the stars everywhere in the galaxy all rotate at the same speed. Now, even then, the stars in the galactic center will make more revolutions quicker than the stars in the arms because there's less distance to travel. Does that make sense, everybody? So that means that this star, or the galaxy, should be winding up. And the evolutionists recognize this problem, and they call it the winding up dilemma. They realize that there's a problem here. Now, this winding up thing should happen actually pretty quickly. If galaxies were more than a few 100 million years old, it would just be this featureless blob of light out there, and you wouldn't see those fantastic spiral arms. However, this is a Milky Way galaxy, or a rendering of the Milky Way galaxy that we live in. Nobody's ever seen it. We haven't gone out that far. But evolutionists will say that our galaxy is 10 billion years old. So why does it still have all those nice, beautiful spiral arms? This is one that we can't see the whole picture, but we certainly see many of them that we can see all those beautiful arms. So there seems to be a problem, so they've devised many theories to kind of overcome this problem, most of which have fallen by the wayside because of exploration and discoveries. One such theory was the wave density theory, that the Hubble telescope actually said, nah, this got too many conceptual problems here. But the latest theory that they're throwing out is called dark matter. Remember falsifiability? Dark matter is something we're going to talk about here. But dark matter basically is the name of yet unknown stuff that supposedly makes up 23% of everything in the content of our universe. You can't see it, it doesn't absorb light, it doesn't emit light, but they say it's there, even though we can't see it. Now supposedly, all the stuff that we can see in our universe only amounts to 4% of everything that's in the universe, which means that the rest of the stuff they call dark energy. So 96% of stuff that's out there, supposedly, we can't see. Now, can anybody prove or disprove that? But what they say is, it's inferred that dark matter interacts with normal visible matter by what appears to be a gravitational pull. So things attract by a gravitational pull. That's, if I had a ball and I let the ball drop, it falls to the earth because the earth is so much bigger in mass that it attracts the smaller object. So what they see out here then, and this is the pinwheel galaxy, what they say is that this gravitational pull from this unseen matter causes the stars to rotate faster than if the matter wasn't there. And they say that there must be some dark matter in between these arms to kind of keep pushing all the star mass from clumping up in the middle here. That's the answer to why they say there's still spiral arm galaxies. So let's just get this straight then. Secular scientists are willing to believe in something that cannot be seen, heard, touched, detected in any way, but they believe in dark matter by faith because it can make sense of what is visible. Well, this is A.W. Tozer. He was a pastor, an author, magazine editor, just a wonderful pastor, and he's still a mentor, even though he's gone, but his sermons are still read by many, many. He's just a wonderful pastor. And in his book, The Pursuit of God, he sums up exactly what it means to believe in God. It says, at the root of Christian life lies belief in the invisible. The object of the Christian's faith is unseen reality. Seems like the same thing the scientists are seeing, right? They believe in something that's unseen, so do we, except for scientists will reject God because they can't believe in something they can't see on the basis of their own science. But God's the one that can provide reality and make sense of the world in which we live in just through His Word. So, two religions are at stake here, right? Man's religion and God's faith in God. So that's the first. Second proof for a young Earth. Comets disintegrate too quickly. Comets are all composed of ice and dirt. They're kind of dirty snowballs. And comets will make these orbital trips around the sun. This is the sun representation here. Now, every time the comet comes close to the sun in this region, it's ice, it's hotter there, so it melts. It lets off the water vapor and debris, and that's what causes the tail of the comets. So every time you see the tail of a comet, it's close to the sun, or closer to the sun, and you can see that wonderful tail behind it. Now, this is a picture, or a couple of pictures, of the Schwarzmann-Walkman, also known as Comet 73P, as it disintegrated, as it got close to the sun. So each time a comet comes close to the sun, it melts and loses more material to the point that it finally just disintegrates catastrophically. And this has actually happened to several dozen comets. This is just one picture here. And so this proves that comets can't survive for a long time. Now, because of the loss of material every time it orbits the sun, most comets should not last much more than about 100,000 years. Otherwise, it loses material so often when it goes close to the sun that it will fail catastrophically and disintegrate as well. Now, evolutionists will claim that comets are 4.5 billion years old as dirty remnants left from when our solar system all formed. So if that's true, comets can't last for any more than 100,000 years, and there shouldn't be any comets today, right? Except for they have a theory that explains this discrepancy, and it's a yet unobserved spherical Oort cloud that lies somewhere out here beyond Pluto's orbit. And it's named after a Dutch astronomer named Jan Oort, named it after himself. And it's supposed to be the birthplace of long-period comets. Long-period comets are those comets that take more than 200 years to complete their orbit around the sun. So long-period comet, more than 200 years. Now, Voyager 1 was a space probe that we launched from Earth September 5th, 1977. And it travels 1 million miles a day. 1 million miles a day, very fast. And at that speed, it would still take 300 years to get to the inner circle of this supposed Oort cloud that nobody knows is there. And it would take another 30,000 years to get through this mysterious Oort cloud. Now, supposedly comets then get knocked out of this Oort cloud, long-period comets, and then they, by gravitational pull, they get pulled into our solar system, and that's supposedly the birthplace of all these long-period comets. Now, this is a quote from Carl Sagan, the late Carl Sagan, who was an atheist astronomer. And even he said, many scientific papers are written each year about the Oort cloud, its properties, its origin, its evolution, yet there is not a shred of direct observational evidence for its existence. Yet everybody believes in the Oort cloud because they have to. It's the birthplace of long-period comets. So even if the Oort cloud were true, it still doesn't answer the question of where all are these short-period comets. Short-period comets are those comets that take less than 200 years to make a complete orbit around the sun. Now, There's another theory called the Kuiper Belt theory. And not to be outdone by Jan Oort, another Dutch astronomer named Gerard Kuiper discovered, invented, whatever you want to call this, the Kuiper Belt theory. And the Kuiper Belt is this hypothetical disk of what we'll call small comet-sized nuclei. It's supposed to be hundreds of thousands of smaller objects in the Kuiper Belt, known as Kuiper Belt objects. And that's the rescuing mechanism for all the short period comets that we should see. Now, I would say that we'll never know in our lifetime whether the Oort cloud is true, not if it's going to take us 300 years to get there and another 30,000 years to pass through it. So we're never going to see that. That's the kind of observation or the scientific claim I want to make, because I'll be long gone. I've collected my money, I've been long gone before they prove it's not true. So, do we know if this Kuiper Belt exists? Well, this is a picture of the Hubble telescope, and it was recently used to conduct a massive study, massive search out into space to find this Kuiper Belt. And instead of finding trillions of these smaller comet-sized nuclei, it only found hundreds of larger objects out there that are tens of thousands of times larger than Pluto and its moon Charon, for example. Incidentally, Pluto and its moon are now considered Kuiper Belt objects because they're that massive out there. So that's a major problem, that you're not finding all this material, this smaller material out there that becomes comets. And even scientists will say, it's a kind of a big blow to our Kuiper Belt philosophy in deep space here. Now, this is a sentence out of the report that was generated from this Hubble study. It says, we see clearly from figure 8 that the theoretical estimates for Kuiper Belt objects are wildly inconsistent with the results of our survey. The best fit observational estimates fall short of the theoretical models by 2 to 4 orders of magnitude. So this means that the comet nuclei that is supposed to be out there are thousands, if not hundreds of thousands of times short of what they expected. Therefore, evolutionists don't have any source for the short period comets either. Now, this is an article from astronomy.com. This was even this year, February 28, 2019. And the title of the article was Craters on Pluto and Charon Show the Kuiper Belt Lacks Small Bodies. And remember, we're looking at small Kuiper Belt objects that become comet-sized that are generally less than 6 miles in diameter. Now, it says, of all the scars on these distant worlds, none are small, challenging astronomers believe about types of objects that orbit far from the sun. And this is the red square, that's the blow up here of the red square. And most of these objects out there are larger than what they would anticipate. This is a picture of Charon. This is one of the moons of Pluto. And note, relatively smooth surface. These are all much bigger than what they anticipated from larger objects that are impacting Pluto. But it lacks those smaller size craters that they would anticipate if there's supposed to be trillions of these. And remember, the Kuiper Belt supposedly starts where Neptune's orbit stops and goes further out beyond Pluto. Well, Pluto is supposed to be right in this Kuiper Belt. So there's a problem there. The article goes on further to quote, from studying these images, scientists have recently realized that while both bodies are covered in craters, almost none of those craters are small, meaning there may not be many small bodies around to smash into them. This changes astronomers' views of the Kuiper Belt. They found that while there are plenty of large and medium-sized craters, there are hardly any smaller than 8 miles across. Since the size of the crater depends largely on how big the impactor was, this points to a lack of impactors smaller than about a mile across. So this is, again, this provides additional problems for the source of these short period comets. Now, both Voyager spacecrafts took off from Earth in 1977, and they have both made their way beyond Neptune and beyond Pluto. So did they find the Kuiper Belt? Well, here's a quote from the NASA webpage. It says, the Kuiper Belt was not discovered until 1992, when Voyager 1 was almost all the way across the region, and Voyager 2 was deep within it. So even though the Voyager team didn't know their spacecraft was in the Kuiper Belt until 1992, the Voyagers themselves collected a lot of data about the region. Well, I'm sorry, folks, but that sounds like you're standing in the middle of the forest and you can't see the trees. If Voyager 1 was right in the middle of the Kuiper Belt and it didn't recognize that it was right in the middle of the Kuiper Belt, you gotta wonder, is the forest even there, right? So, problems here. So what does all this mean in terms of comets then? There's not a source that provides either short or long period comets. Comets shouldn't last for more than about 100,000 years, yet scientists say they're 4.5 billion years old. So that means that the universe has to be younger than 100,000 years, right? Does that make sense? Now, I'm not saying the universe is 100,000 years old. I'm saying, using the same uniformitarian principles that they do, there's problems, because you still don't get the 4.5 billion years that they claim it is by using their own science against them. Evidence number 3, there's not enough sediment on the seafloor. Now, the seafloor has a lot of the same geologic features as the land masses do. There's valleys, canyons, there's buttes, mountains, ridges, and it has lots of sediment deposits. Now, before I go any further, I'm going to give you another quick summary of tectonic plates. Now, think of the Earth as an egg with all these broken eggshells on it, and those eggshells move with respect to one another. Those are called the tectonic plates. And those plates move relative to one another along these boundaries. And remember that nearly all these boundaries is where most of the earthquake and volcanic activity takes place. And so keep this in mind as we dig further into this, because every year through a bunch of different sources, whether it's rivers or glaciers that are pushing ice and sediment into the sea, or sand-blown dust, but all the sources only dump in 27.5 billion tons of sediment into the ocean a year. 27.5 billion tons of sediment. A lot of sediment. Now, the only way to remove sediment, then, is from what we call subduction, where one of these plates slide underneath of the other plate. So, oceanic plates are more dense, they're heavier than continental plates. So it's the ocean plate that will slide under the continental plate. And when it does that, it will pull in sediment down and basically recycles that sediment down into the earth. Now, scientists will say that that's probably only accounts for like 1 billion cubic miles. So there's still 26.5 billion miles per year that accumulates on the ocean floor. And at that rate, it would take less than 12 million years to get the sediment thickness that we have on the ocean floor, which is about 2,950 feet of sediment. That's kind of an average. There's some, obviously difference whether you're, on a shelf or not on a shelf, but a good average is about 2,900 feet. It would take less than 12 million years at that deposition and that removal rate. Now, according to evolutionists, they say that this subduction process has been going on for as long as the oceans have existed. That's anywhere from 1 to 3 billion years. So if that were so, at those current rates of 26.5 billion tons of accumulation, in just 1 billion years, the sediment would be 18.5 miles deep. We don't see that, so where's all the sediment? Well, here's an alternative explanation. After Noah's flood, when God raised up the mountains and all the water ran off the continent, massive amounts of erosion would have taken place at that time, washed all the sediment that we see into the oceans, and now it's just building up gradually since that time. So you don't need millions and millions of years. This can happen very quickly. Evidence number 4 for a young Earth, then, the continents have not eroded away. I mentioned that 27.5 billion tons of sediment were being dumped into the oceans per year. That's a huge amount of sediment. So in practical terms, what does that look like? Let's say you have a train, and every boxcar has the capacity for 11 tons of sediment. 11 tons of sediment per car. It would take 2.5 billion cars to hold that sediment. And if you're looking at how long this train would be, it would go to the moon and back 34 times, 2.5 billion cars. And if you were standing at the track and the train was passing you at 60 miles an hour, it would take 31 years for that train to get past you. That's how much sediment we're talking about is being dumped off of the continents into the oceans. That's a lot of sediment, isn't it? And that's per year. That's happening per year. So how long would it take to erode the present continents then down to sea level at that rate? By looking at all the mapping that we have, scientists will say there's about 30.4 million cubic miles of continental coast and crust above sea level. And that is about a mass of 383 million billion tons of material. 383 million billion tons. And at a removal rate of 27.5 billion tons a year, it would only take 14 million years to erode our present continents to nothing. Now, evolutionists say that our continents have existed for 1 billion years. And so during this supposed interval time, the present continents could have been eroded 70 times by now. Yet, miracle of miracles, they're still there. So evidence number 5 for a young world then. There's not enough salt in the oceans. Now, ocean water contains about 3.5% salt. And that salt is either in the form of chloride, sodium, sulfate, magnesium, and there's a little bit of calcium and potassium and some other minor stuff here. So if you look at just table salt, sodium chloride, that makes up about 85% of all the salt in the ocean. Now, if the oceans were completely dried up and you scraped all the salt together, you could build a wall, a salt wall, 1 mile wide, 180 miles tall, and it would go all the way around the equator. That's a lot of salt. That's also equivalent if you took all the salt and you just spread it across the continents evenly, it'd be a depth of 500 feet, basically a 40-story building. So a lot of salt in the ocean. Now, the input of salt in the ocean is about 450 million tons per year. That's from the continents, the dirt, the earth, the sediment has mineral salts in it. That's what's giving the oceans all their salt. And only 27% of that is being pulled out every year by salt spray and some evaporation. So that means that 73% of the salt accumulates in the ocean. Now, if the sea had zero salt to begin with, which is not very likely, but we'll give the best scenario. If it had zero salt to begin with, it would have accumulated the present amount of salt in less than 42 million years. So again, I'm not saying that the Earth is 42 million years old. I'm saying it's still far less because they say that our oceans are 1 to 3 billion years old. So you can have that much salt in the ocean in less than 42 million years. If they were older than that, if they were 3 billion years old, there would be so much salt in the ocean then it would be like the Dead Sea. It wouldn't even support life. There'd be too much salt in the ocean. So there's obviously not enough salt to be billions and billions of years old. Evidence number 6 then for a young world. The Earth's magnetic field is decaying too rapidly. I mentioned this in one of the other lectures that I had. I just kind of wanted to go over this again. The Earth basically acts as a big bar magnet with the north and the south pole, and these flux lines then go from the South Pole to the North Pole. And scientists don't fully understand where the magnetic pole comes from or where a magnetic field comes from. They can only surmise the composition of the Earth, but they think there's a solid inner core, then a liquid outer core, a mantle, and a crust. Now, they surmise that because of the earthquake, the seismic waves that propagate across the Earth whenever there's an earthquake. And there's P waves and S waves are the predominant ones, but the S waves don't propagate through water or molten material, lava, and things like that. So that's how they think they know the composition, but we've not drilled even close to being deep enough to get down, even into the mantle area very far. But according to scientists then, this outer core is made up of nickel and iron that kind of swirls around by thermal activity, and that with the rotation of the Earth, it generates basically an electrical current, and then that electrical current generates this magnetic field. It's kind of like taking batteries and hooking them together with a coil of wire that induces a magnetic field. This other thing that's very similar. It's called the dynamo theory. Again, nobody really knows for sure because we haven't drilled that far. But the magnetic field then protects the Earth from the solar winds from the sun that eject streams of ionic material. And it provides this buffer then that deflects those solar rays, and then in front of the Earth and back is what's called the magnetosphere. And these solar winds, they fluctuate based on sunspot activity. So the more sunspot activity there is on the sun, the more dangerous radiation that you get from the sun. Now, you've seen this graph before in one of my other lectures. This is just a small snapshot of the intensity of the magnetic field since 1900 to 2000. It's been declining all this time. And actually, the first time when this magnetic field has been measured was 1845. And what they found out is it's 10% less from 1845 to 2000. Now, extrapolating that data back, then they say every 1,465 years, the magnetic field should decrease by half. Now, the magnetosphere is supposed to be 3.5 billion years old. If that's the case, the magnetic field would be so weak today, you wouldn't be able to detect it, or it would have been so strong in the past that it would have had serious ramifications on life on Earth. So we don't think that the Earth is that old. Now remember our plate tectonics boundaries that we talked about. These are the ridges where those plates come together. They're also called the oceanic ridges. Now this one here between the North American, South American, and Africa and Europe, that's the Mid-Atlantic Ridge. And this picture is kind of a representation of what happens along this oceanic ridge. But the magma comes up through the crust, and as it comes out of the ocean, the surface of the ocean, the bottom of the ocean, it spreads the continents farther apart. At sometimes centimeters per year. So scientists will look at that, again, using their uniformitarian principles, and they'll say, well, this little bit of magma that comes up and spreads the continents apart happens just a little bit, so these continents have taken millions and billions of years to spread out to where they are now. But if this happened when all the ocean crusts were breaking up, when the fountains of the great deep broke forward, and the continents were, this lava was coming up quickly, we call that continental sprint. These continents were moving apart at feet per second, possibly. So just, again, a difference in how you look at the data and what the data is based on. Is the data based on God's word, or is it based on man's word that says, oh, this is slow geologic processes that have been happening for millions and billions of years? Now, it's interesting because as the magma cools, as it gets pushed up here and it cools, it becomes permanently magnetized in the direction of the Earth's magnetic field at the time. Now, evolutionists will say that the magnetic poles have actually flip-flopped from north to south several times. In fact, they say over 170 times during the last 100 million years. And they see that because as a ship will sail across the ocean, it will pick up different blips as it's going across the ocean floor. Now they say that the average time between these reversals is about 200,000 years, except for the last reversal was 780,000 years ago. So their cycle is certainly interrupted, hasn't it? Now here's a different theory that I think makes more sense, and it is true from what we see. Observational science does show that the magnetic field has reversed several times. But creation scientists will say that after the fall, the Earth's magnetic field started to decay when God cursed the creation and everything. And it continued to decay until Noah's flood, and then when the fountains of the deep broke open, and it's ripping apart the crust of the Earth, all this magma is coming up. There probably could have been several magnetic reversals at that time. And that's what we see is a lot of magnetic reversals, and then some minor fluctuations until now we've just seen a steady decline ever since. Does that make sense as a more biblical model than 200,000 years old, but yet there's still 780,000 years since the last reversal? Certainly makes more sense to me from a biblical perspective. Now there is a science called archaeomagnetic dating. It is the study of the signature of the Earth's magnetic field over time as it's recorded in pottery and fire hearths. Now when you burn clay at very high temperatures, all the magnetic minerals, irons and magnesium, all things that are metal, stabilize, and instead of randomly oriented, they all get stabilized and they're all kind of pointing in the same direction. So when you look at that, it locks in, when the rock or the pottery cools, it locks in the direction and the magnitude of the magnetic field. So observational science does say that it has reversed. Now this is one of the dating methods that people use, and Mark, I think you had the question one time, is, do they use it on things that aren't metal, like carbon dating? This is what I mentioned here, this archaeomagnetic dating, that they do use to date things that are less than 6,000 years old. So this fits in very nicely with the biblical principle here. And from the pottery that we've seen, data points all over the world, it says that the intensity of the Earth's magnetic field was about 40% greater in 1000 AD than it is today. So you've seen this continuous decay. Now, creationists of the 1970s, probably 70, early 70s, they extrapolated all that science back into the past, and they said that the Earth's magnetic field could be no more than about 10,000 years old. That's one of these examples that fits the biblical chronology quite well. Number 7, sediments are too tightly bent. I think I talked about this when we talked about our geology lecture. But in many areas, we see many, many different layers of rock, sediment, that are hundreds of feet thick. This happens to be in the Grand Canyon, and just for scale, these are people here. So massive layers of sediment, but they're bent, sometimes in these hairpin fashions. Yet that folding occurred without the rock cracking. So the entire formation, all the different layers, would have had to settle out at the same time and then bend before it had a chance to harden. And this implies then that all the layers were laid down in very short succession, and then after they were laid down, not over millions and millions of years, but before they had a chance to harden, they were bent, and they were all bent at the same time. Now, the conventional theory is that geologic time, one sand grain falling on another, until one layer of sediment formed, and then it hardened, and then there was another sediment layer that built up on top of that, and it hardened, and then all of it was just folded up together. But when we break rock, right, the top of the rock is in tension, it's a tensile force, the bottom is in compression. So when you bend the rock, it should fracture on the surface here, but it doesn't. So the only way for this rock to be bent, again, is for all of the sediment during Noah's flood to have settled out of suspension and then folded rapidly after it was all there. Since I spent a lot of time on that with the geology, that's all I'm going to say about rocks. Number 8, helium is in the wrong places. You say, well, where is it? Well, all naturally occurring families of radioactive material, when it decays, remember in our discussion on radiometric dating, it decays from a parent isotope to a daughter isotope. And when it decays, it generates helium atoms. And that's the same thing when uranium-238, which is radioactive, when it decays to lead-206, in these zircon crystals, which are in granite rocks, granitic rocks. When it does that, it generates helium atoms. Now, the loss rate is so high that most of this helium should have escaped in about 1.5 billion year age of this rock, right? Granite's, they say, well, granite's about 1.5 billion years old. Well, we would expect to see a large amount of helium in these zircon crystals, but scientists studied it and they said, no, it sneaks out way too quick. The diffusivity rate or the leakage rate is very quick. Now, the helium loss rate is so quick that it should have lost all that, but the crystals in the granite rock still contain lots of helium. So it should all be gone if it's 1.5 million years old, but there still is a lot of helium. And they say based on the current rate, the leakage rate, that they have only probably been leaking helium for about 6,000 years. Again, this fits the biblical time scale very well, because there's still a lot of helium in these zircon crystals. But the evolutionists say that the Earth's atmosphere is 5 billion years old, and if the decay rate of that radioactive element that has taken place for 5 billion years, there should be a lot of helium from the rocks that escaped up into the atmosphere. But that loss rate, and people say, well, the loss rate from the atmosphere into space is probably where all that helium is going. Actually, that's a very negligible amount of helium loss into outer space. So most of the helium in the rocks should have escaped out into the atmosphere, but the atmosphere has only 0.05% of the amount of helium that it should have based on the 5 billion year old and how fast the helium is leaking out of these zircon crystals. So where's all the helium? It's still in the rocks. It's not in the atmosphere. It's still in the rocks. So the Earth can be billions of years old. Evidence number 9, the moon is too close to the Earth. The moon moves away from the Earth about 1.5 inches every year. And it's primarily because the moon does have a gravitational pull on the tides of the Earth. That's where our tides come from. The tidal waves come in and out. So when this tide pulls forward, kind of the mass of the Earth kind of shifts, and it allows the moon to spiral out from the Earth's gravitational pull. Now in the past, that means the moon would have been closer to the Earth. And 6,000 years of what we say is the age of the Earth or the universe, that would have only been a distance of about 800 feet. Pretty negligible in terms of how far, 221,000 miles away, so pretty negligible. But that just says, well, the 6,000-year time frame makes sense. However, the Big Bang supporters say that the Earth and the Moon are 4.5 billion years old. So if that same recession rate, 1.5 per year, took place over 4.5 billion years old, or 4.5 billion years, the Moon and the Earth would have been touching each other in less than 1.5 billion years. So to have it be 4.5 billion years ago, the science doesn't work, the dates don't work. And then finally, evidence number 10, DNA decays too fast. And I went over this last time as well. But DNA cannot last for much longer than about 100,000 years or 10,000 years, several tens of thousands of years, let's say. Let's give it the benefit of the doubt. But there was Bob Hartman discovered a T-Rex fossil in Bozeman, Montana in 2000. And Mary Schweitzer, another paleontologist, took samples of the bone, brought it into the lab, and what she found shocked the world. And that was soft tissue that was still spongy, still stretchy, still resilient. So how did it last 65 billion years? Because that's what scientists say the last dinosaur died out 65 million years ago. So if DNA can only last about 10,000 years and we're still finding soft DNA material, it can't be 65 million years. We still find intact strands of protein and DNA in fossils from Neanderthal man, from insects that are captured in amber. So it can't be 65 million years old. But when the evolutionists looked at the data, they said, well, maybe DNA can last for 65 million years. Instead of just saying, you know what, we're wrong, we can only be tens of thousands of years old, they said, well, maybe it could. Maybe it's possible that it can last 65 million years. Now, here are 10 evidences that we've gone over fairly rapidly, so I hope a lot of them made sense to you. But these demonstrate that the Earth can't be millions and billions of years old. Now, using the same arguments that they do, the uniformitarian principles, we just can't be millions and billions of years old. And many of these still show dates much younger. We saw some that are within that biblical time frame using uniformitarian sciences. Now, I'm not saying that these ages for millions and millions of years are correct again. I'm just saying those are the maximum possible using their scientific reasoning. But this still leaves much reason to believe that the Earth is much younger. So there are many examples here that prove the Earth is only thousands of years old, and that matches what the Bible says. So the main difference basically is, where do you start from? Do you start from the fact that God's Word is true, and that everything that we read from Scripture we can take just as God had told us? Or do we say that man is the one that decides truth, but his logic and his methods change all the time? There's new history and new science textbooks that are generated every year just because we found something different. So ultimately, why does it matter? Does it really matter how old the Earth is? From a salvation standpoint, no. But from an authority standpoint, it does. Because when you start picking and choosing out of this book what's true and what's not, and well, creation account is true, so I'm going to kind of wedge in millions and millions of years of man's fallible theories, then all of a sudden you have to have things like millions of years of death in the fossil record before Adam and Eve sinned. If that's the case, then death isn't a result of sin. So if it's just all an allegory, then there wasn't a literal garden, there wasn't a literal Adam and Eve, there wasn't a literal first sin, then why do you need a Savior? But that's what this book is all about. Really, it's the fall of man, that we're broken, we can't do it ourselves, we have tried over and over again throughout history, we're still trying today. But the Bible's true, and there is a Savior, and he came into this world sinless to live a perfect life, to die on a cross, so that we don't have to suffer for our own sin. So if this is all an allegory, we have a problem, don't we? So that's why it really matters. And that's why the point of this lecture tonight was just to lay that foundation. Because starting next week, we'll be presenting some of these compromising views from old earth creationists, all different people out there, even secularists that will say, well, no, you'd have to do this, if the Bible's true, you'd have to fit this in there. So we're going to look at several theories. We're going to look at theistic evolution, the gap theory, progressive creation, what's called the framework hypothesis. We're even going to look at the intelligent design movement and see what that has to do about what the Bible says. So these are all theories that people will use to fit millions and billions of years and try to harmonize science with the Bible. And I'll say we don't need to do that. God's word can stand on its own.